We will solve the following exercise. The exercise is at number 2.10. The forces acting on the sailplane are represented by three vectors. The lift L and drag G are perpendicular. The magnitude of the weight W is 500 pounds. The sum of the forces W plus L plus D equals 0. Graphically determine the magnitudes of the lift and drag. Okay, as you can see right here, the lift is a force, and it is always be pointing perpendicular to the airplane, aircraft, or in this case the sailplane. The drag is going to be always pointing to the opposite side of the direction of the airplane, in this case the sailplane. And the weight always points toward the earth, the center of the earth, in this case down. Okay, as you can see right here, they are telling me one statement. I think this is the principal one, and is that W plus L plus D equals 0. And I want to explain what is happening here using, for example, these three vectors, right? For when I have these three vectors and they are asking me, I want to create a summatory of these three, graphically speaking, then what I have to do is to move one of the vectors touching tail with head with one of the other two vectors, okay? And I'm going to do the same thing with this vector. The result will be the vector generated between these 2 points. Between these 2 points. And the generated vector is going to be generated the other way around. So the tail must be touching the tail and the head. So right here I have the head of the resultant vector. I could have done, for example, a different shape. So for example, I have this shape, and the result will be the same. Okay, now that I've made that clear, I have something like this in this case. This looks more like this. As you can see right here, I have W, the lift, and the drag. And by graphically creating a resultant shape, there is going to be generated a closed shape, right? So as you can see right here, I cannot create a resultant vector because everything is connected. These three vectors are connected with each other. Alright? So the resultant vector, since I cannot create it, it is going to be equal to 0. Right? So once I have this and I want to create, or I want to know these two magnitudes, then what I have to do is to start playing with trigonometrical identities, okay? So this is telling me that I have an angle of 25 degrees between the weight and the lift. So weight and lift is right here, so this is equal to 25 degrees. The second thing that they are telling me is that the lift D and drag D are perpendicular. That means that between these two I have a 90 degrees angle. I have a corner, right? They're also telling me the magnitude of W, which is equal to 500 pounds, but I don't really care about the unit system right now. And they are asking me for the magnitude of D and L. Alright, so what I have to do right here is to start playing with trigonometrical identities like I said before. I want to know this angle. I'm going to call it, for example, alpha. And for me to get that angle is pretty easy because there is one statement, and the statement is that the summatory of the angles within a triangle must be equal to 180 degrees. So 25 plus 90 plus alpha equals 180. That means that alpha is equal to 180 minus 90 minus 25. Okay, 90 minus 25 is equal to 65. So that means that alpha equals 65 degrees. And I already have all the angles within the triangle. So what I'm going to do is to apply the sine's law. The sine law. In this case, this is generated by a correlation between the angles, sines of the angles, and the magnitudes. So L divided by the opposite angle, which is alpha, sine of alpha, is going to be equal to W divided by sine, in this case of 90, and this is going to be equal to T divided by sine of 25, right? I already have this value, so with this value I can get these two by just taking this part of the equation and this part of the equation. So as you can see right here, L is going to be equal to W divided by the sine of 90 multiplied by the sine of alpha, and D is going to be equal to this multiplied by the sine of 25, right? So as you can see, I'm regarding the magnitude and the opposite angle. Then I'm going to use the calculator. I want to make sure that I've done this correctly, so bear with me. It's 25, yeah, so it's okay. Then 500 divided by sine, and I have to make sure that I'm using degrees right here, of 90 multiplied by the sine of alpha. In this case, alpha is equal to 65. Okay, so L, the lift, is equal to 453.1538. I always use 4 significant digits after the comma, and these are pounds. Now I do care about the unit system. And the drag is equal, but changing this for 25. 211.3091 ounce. Right? Have the answers. And there is one way in which I can check that these are correct, and it is by using a software. In this case, I'm going to use CATIA V5, and all I have to do is to create a shape, the shape of these three vectors. Right, then I'm going to constrain what I have right here. I don't know why this is not working. I think that I have some technical problems. I don't know what happened. Okay, Okay, the thing is that the mouse is not working anymore because I always pressed. Okay, right now. Sorry for that. I get scared because my mouse is brand new. So, all right. Yeah, it's working now. Right here I have this measure. Right here I have I have this angle, and I have this angle. Yep, this angle. So as you can see, the software is showing me in green that everything is defined and that I cannot move anything. Remember that you have some tutorials regarding this tool, CATIA V5, within the channel for you to learn how to use it, okay? Then what I'm going to do is to change the values. Right here I have a 90-degree angle. Right here I have 25 degrees angle, and this is equal to 500. Okay, and this change the shape. All right, so what I have to do is to measure, and that's all. Reference and reference. Right here, as you can see, I have the two measures that I got right here. So everything is correct. I can be sure of it. 453.154. This is approximating to the next value, since I have here a number that is above 5. That is a topic regarding approximations. But yeah, that is basically what happens. When I have, for example, right here a number that is between 1 to 4, including these two, then I must stay with this number, okay? In this case, this would be equal to 453.153, okay? But if I have a number between 5 and 9, I can approximate this value to the next one, in this case a 4, okay? So this is what this software is doing right now. And the same goes for this. As you can see, I have right here a 1, so this is staying with this number. And that's all, guys. This is how this exercise could be solved and checked.